There's one more special case, and this is one that at first seems confusing. Once you get it, you just fly through the problems that are like this. It's pretty cool. I mean, cool for math. If you're not into math, it's hard to make math cool, but math can be pretty darn cool. Really stinks that I'm gone on a Thursday when it's only a 3-day week. Believe you me, I'd rather be with you guys right now than what I'm doing. But ironically, or not ironically perhaps, I am at a class which allowed me to get the Chromebooks so that when I miss, you can learn via Chromebooks. So because I missed this time, to get those Chromebooks, you're currently on the Chromebooks that I got for missing. Mind blown yet? Alright, you know what's less complex than that last sentence? Learning the difference of squares. Alright, so again I'm going to start by showing you how to simplify something that is the difference of squares. If I multiply this out, I get x squared. I would get positive 3x. Actually, let me do this in order so I don't confuse anybody. X times x, x squared. X times negative 3, negative 3x. The insides now. Positive 3 times x plus 3x. Finally, positive 3 times negative 3 is negative 9. Now when we combine our middle terms this time, we're going to have negative 3x, positive 3x. Those things cancel each other out. We're simply left with x squared minus 9. When we have the difference of two perfect squares, our answer is plus or minus the square roots of those two things, right? Square root of x squared is x, square root of 9 is 3, so it's plus 3 minus 3. And that's our answer. As a little tip, when you're doing your problems, if you only see two terms, ask yourself, are both terms perfect squares? If so, it probably factors rather easily. Let's try it. How about x squared minus 25? I only see two terms. The first one's x squared. Is x squared a square? Kind of by definition. Is 25 a perfect square? Sure, it's 5 times 5. So here's what I do. I write an x in each side. I write a 5 in each side. Just one of them's plus, one of them's minus. That's my answer. This trick is so easy that it's the first time you can actually see doing the more complex type where you have a lead coefficient. Let me explain. 4x squared minus 100. Looking at that right off the bat, you're like, oh, 4x squared, what I got to do now? It's a little overwhelming at first, but then you're going to remember, hey, Walsh said when I just have two terms, let's check and see if they're both perfect squares. Well, 4 is 2 times 2. X squared is x times x, so 4x squared must be a perfect square. 100 is 10 times 10, also a perfect square. Sounds like we got a good deal. I'm going to put two sets of parentheses. The square root of 4x squared is 2x, so I write that on both sides. The square root of 100 is 10. I write 10 on both sides. And since it's the difference of squares, plus, minus. Now you're factoring like a champ. Right? Now later we'll talk about how you could pull even more out of this one. You could pull out the 2. But for right now, simple factoring is fantastic. I know what you're thinking, Walsh. You a mathematician or a mathemagician? Whoa. Alright, that's it for today. Get on to your homework. Maybe you'll get it all done in class, because I know you focus extra hard when I'm not there. Get it all done, and don't worry about having anything tonight, Tim. You know I'm talking to you. Alright, folks. Hasta mañana.